Hello again, everyone. Welcome to another episode of Clean Critically. Today, we are going to discuss wash, rinse, and dry. More excellent ideas for manufacturers brought to you by the Product Quality Cleaning Workshop team.
Consisting of Darren Williams, the professor, who is professor of physical chemistry, Sam Houston State University, and head of the cleaning research group there.
At BFK Solutions, who are experts in critical cleaning and contamination control. It consists of Barbara Koenigsberg, the cleaning lady, and Ed Koenigsberg, the rocket scientist.
So you're going to learn a little bit about washing, rinsing, and drying. You'll learn a little bit, but not everything. So we'll start with a little bit of is it a reminder or a shameless plug? For our product quality cleaning workshop, aqueous cleaning on demand course. You learn at your own pace, you get continuing education credits, and you get a half-hour discussion with a PQCW instructor. I'm told it's more fun than a bubble bath, although I like a bubble bath. Anyway.
Okay, so let's move on.
Okay.
Well, you clean your hands, you clean a dish, and you clean product. All of these involve the steps of washing, rinsing, and drying. But you always have to ask, why?
What are you doing? Why is each step necessary? Darren, you want to start with washing?
Sure. Well, of course, if you saw that picture before with all the food and everything, I would pull my hair out, what's left of it, to see that much soil and residue on the plates and things. You need to remove all of that, and many times it's small. You can't see it very well, and so you need to wash to remove that soil, that residue, and still you want to avoid product damage. You don't want to change the surface to an undesirable state, and sometimes with like ferrous metals, you have to worry about corrosion.
And you don't want to redeposit the soil on the part.
And the washing is sometimes referred to with other terms. Up at the top, we use deblocking, which is a term for optics, deflecting for electronic circuit cleaning.
And cleaning.
And just
That's
cleaning.
right, yeah.
And we always worry if there's more soil on the part at the end of the process. If you see that, that is a warning sign.
That's right.
So why are we rinsing, Ed?
Well, one thing is you have more soil that has to be removed. The soil at this point, which is anything that is not wanted, includes the cleaning agent that you use to do the washing.
Mm-hmm.
Again, you've got to avoid damage to the surface, corrosion, and redeposition of the soil.
Product damage, staining, anything.
That's right, yeah.
So who would like to cover this? Me?
Well, I would like to jump in on the aqueous. A lot of times the aqueous cleaners, you have the surfactants and you have the pH adjusting chemicals. You have lots of things in the aqueous, and that's what we're talking about. You don't want to leave any of those things behind because you've brought those into and close to the surface. So the rinsing really pulls all of those things away. So you need to rinse away all of those components in your aqueous cleaning formulation.
If you're using a solvent for degreasing, you still may need to do rinsing. If you're using a vapor degreaser, you're doing a self-rinse in the vapor of that solvent.
It's terminology, but if thinking about it, the vapor degreasing part of vapor degreasing can be used as a self-rinse. There are also a lot of multi-step processes with different names that are only semi-intelligible to everyone, but basically semi-aqueous is where you use a water rinsable solvent, so you rinse with water. There are co-solvents and bisolvents where you have sequential solvents, and the rinsing part is a displacement agent. The cleaning agent is often called the solvating agent. Sometimes there are 3 or more cleaning agents in a row. It depends. Why do you want to dry?
Well, again, you're at this time point, the soil that you're removing is the undesired material, either the water or the solvent that you've been using for your wash and your rinse. Again, as in all of the steps, you want to avoid things that do damage or modify the surface in a way you don't want it to be, corrosion and redeposition of any soil. And that can be either particles or oils.
And we've seen
Yes.
examples where people have used shop air for drying, and you can find oil deposited on the part.
Perfectly clean part
Ew.
going into the dry, not so clean coming out of the dry.
Yeah,
So
that's a disaster.
Gross, technical.
And this is where any impurities in your rinse are going to be deposited on the part, especially if they're non-volatile. That's where those particles can come from.
Yeah.
And
then
also
if
some
you
of the
dry-
non-volatile oils that may be in your rinse
true.
that they get stuck on the part.
The heat of drying can sort of drive in some of the soil, some of the particles.
Yeah.
Have to be a little careful.
Yes.
Drying is generally ignored or underfunded. It's the last step. People forget about it. It's important for solvent and aqueous to prevent corrosion, remove solvents from blind oils, avoid solvents outgassing from plastics, minimize solvent emissions, all that stuff. And it's often the rate limiting part of the process, drying time and cool down time. With water, it can be very, very energy intensive because of the heat of vaporization.
Which is
And that's
about
true of any steps.
Yeah, but the heat of vaporization of water is about 10 times that of the common cleaning organic solvents.
And if you don't plan it right, it can be a bottleneck. So you want to avoid that.
Right. And that can be an unplanned cost. You need to take into account the energy.
Absolutely.
Yes.
So to summarize, who would like to discuss the goldfish cleaner? Don't everyone see it?
Yes. Well, I love this diagram just because it shows that batch process. You've got maybe several washes. Maybe you have, a different solvent type wash or different aqueous cleaner, or maybe you're doing a finishing line where you have a deoxidation and then, a surface prep step. And then you have the rinses, more smaller rinses are better than one large rinse. And then you have the drying step. And you can see that goldfish is getting nervous about the drying step.
I've always, and coordinated process design and control is essential. So if you're putting together a process, get everybody together and singing Kumbaya at the beginning. It's really important.
Yes.
So we leave you with these thoughts, these ideas. We would encourage you to ask yourself about the functions of the cleaning process that you have, and to think of some ideas. Think of what you would do in washing, rinsing, and drying. If you would like to talk with us, to contact us, any of us were there. We really welcome your ideas. And we want you to call us, to think about it, and to keep asking us why.
Absolutely. All right. So we'll see you next time on the next episode of Clean Critically.